Okay, so in a previous video, we took a look at this compound interest formula and made sense of what all this crazy stuff is talking about and how it shows us how our money grows or how our debt can grow. Okay, so let's take a look at a second example for those of you that like to see that worked out again. So this example says find the account balance after 20 years if $10,000 is placed in an account that pays 1.2% annual interest compounded twice a month. So we want to basically figure out what we know out of all these variables. We got A, P, R, N, and T. We got to see what we know. Okay, so let's take a look for A. I just go left to right, just kind of reading like a sentence and just going step by step. So A is the amount that's currently in the account. Well, it says find the account balance. So I don't know that. So we get a question mark that thing. Okay, next up, what is the principal or the amount we're starting with, right? That's just like the fancy banking way of saying how much money we're starting with. So right here it says we're putting $10,000 in the account. So P is going to be 10,000. Okay, as we're reading across, we get this parentheses 1 plus. This is always the same. We don't have to worry about that. That's what makes it grow exponentially. Remember what you have to add 1 to make exponential growth happen. So then we get to this fraction R over N. So now we got to figure out, well, what is R? So R is the annual interest rate written as a decimal. So we look over through this problem, and here's our 1.2% annual interest. And if you're trying to go too fast, you're going to write down 1.2, and you're going to get the problem wrong. So don't do that. Remember, it has to be a decimal. You got to slide that decimal point 2 places to the left. So this is going to be 0.012 for R. Next up, we come to our variable n. N is the number of times compounded per year. So we got to read through the problem and think about how many times are they going to calculate interest or compound this thing. And it says it's compounded twice a month. Okay, so 12 months in a year. It's going to happen 2 times a year, or 2 times a month. So twice 12 is 24. So n is going to be 24 for this problem. And then we've got the number of years, t. How many years are we waiting? We're waiting 20 years this time, so we're going to see pretty good growth on our money after 20 years, we hope. Okay, so once we've figured out what these variables are for this problem, we just plug it into the formula. So we don't know A, so it's a variable. A equals P is 10,000, parentheses 1 plus, always the same, we don't have to worry about that. For our fraction, we've got R, our interest rate, 0.012, over the number of times compounded, 24. And then we got to grab our exponent, and that is n times t. So 24 times t, 20. So 24 times 20, that's going to give us a pretty large exponent, okay? That's sort of offset a little bit by dividing by a larger number down here. We're going to get a smaller decimal in this place, so it's going to balance out a little bit. At this point, once you've got everything filled in, we just grab the calculator and we type that stuff in. Okay, so $10,000. Parentheses 1 plus, so you don't have to mess with time signs and stuff. To get a fraction, you can hit alpha y equals and enter, and that's going to give me a fraction bar. So I'll put my 0.012 in the top for my interest rate, and the bottom is compounded 24 times in a year. And then we want to put our exponent again, 24 times 20 years. Oh man, what's our money going to grow to? Let's find out. $12,711. Well, okay, so it grew $2,711 in 20 years. Yeah, maybe that's not that great of an annual return after all. 1.2% interest is not very high interest rate. So, but hey, it's free money, so I'm not going to complain about that, right? All right, so $12,712 if I round these cents up. So 12,712. So $12,712 bucks. That's going to be our answer for that one.